Here is the next example. In this example, he's asking us to find the state equation, output equation from the given mathematical equations, or mathematical equation. Actually, there is only one equation. By using controllable canonical form. Why are we doing this in controllable canonical form? Because he want to make that system is controllable. Okay. Anyway, when we convert this into S domain, we will end up with s square minus 3s minus 2 times y equal to s minus 1 times u. Basically, the dot u dot, you can write it as s times u. Okay, that's how I got this mathematical equation. Same way, y double dot equal to s square times y, and y dot equal to s times y. Okay, now if you look at this mathematical equation here, so y over u, output over input, y is the output, u is the input for the given system, s minus 1 over s square minus 3s minus 2. So this system has, the order of the system is 2 based on the number of poles. So this system has 2 poles and 1 0. The poles represent whether the system is stable or not, and the zeros represents how fast it can be stabilizable, or how fast it's going to come to the neutral. I mean to say how fast the curve is going to settle down, so without much change in the output. That's what number of zeros tells us, or the numerator gives us. Now, in the previous example, you always have y over u equal to 1 over something. Okay, so there were no zeros, so that was easy. Now here I have some zeros. So what I'm going to do, I'm going to define one more variable. So that variable, I'm going to write it as, or I'm going to make the system. So basically, here is a system. I have h, here is my output, here is my input. So what I'm going to do, this system, I'm going to break it into 2 subsystems, h1 and h2. Okay, at the end I'll still have y and u here. Okay, now the variable here, I'm going to define that as z. So I'm going to write this z over output over input equal to h1. I'm going to write this as 1 over s square minus 3s minus 2. Same way, y over z, which is equal to h2, I'm going to write this as s minus 1. So when I combine these two, y over z times z over u, it doesn't matter which way you write it down, it's basically s minus 1 times 1 over s square minus 3s minus 2. So we'll end up with the same equation. So okay, I'm not making any changes with the given system, but I'm making that as a 2 subsystems, h1 and h2. Now, so what I'm going to do, so if you look at h1, so system 1, I'm going to write this as s square minus 3s minus 2 times z equal to u. So basically, so zs square, so it's basically z double dot minus 3z dot minus 2z equal to u. So z double dot equal to u minus, okay, u minus, or u plus 3z dot plus 2z. Okay, that's my z dot, double dot, sorry. Same way, the h2, system 2 will end up with y equal to, or system 2 y equal to basically z dot minus z. So when I bring this to the other side, we'll end up with basically system 2, you have y equal to s minus 1 times z. So we'll end up with that. Okay, so let me draw this first and then a simulation diagram, and I will draw the simulation diagram for that next. Okay, so z double dot, there are two integrators. So I have two integrals here. I'm going to take this as z, that's a z dot, and then z dot, z double dot. Okay, how did I get the z double dot? I have u coming in and 3z dot, that's a positive, and 2z, that's positive, and 2z. Okay, so this is the system 1. Now to get y, my y is somewhere here. Y equal to z dot. Okay, I need to get a z dot, and it's a minus g. So basically this is plus and this is going to be minus. That's how we'll end up with y. That's all. We added all two systems. So now I'm going to have the state variable. I'm going to have x1 dot, x2 dot. Okay, now we can try to write down the state equations. X1 dot, or state equation, will end up with two state variables though. Okay, so x1 dot equal to x2, and x2 dot equal to 2x1 plus 3x2 plus u, and the output equation y equal to minus x1 plus x2. Okay, so this is my output equation. These are my state equations. I'm sorry, these are equations since there are two. Okay, state equations. Okay, now if I write it down in the matrix format, A equal to 0 1 2 3, B equal to 0 1, and C equal to minus 1 and 1, D equal to 0, D equal to 0. I'll stop this video here. I'll continue in the next video with few more examples. Thank you.